This is the continuation of the review worksheet for Unit 8, Math 2. We're going to do number 17, 18, 20, 21, 23, and 24. And keep in mind as we're doing these problems, the instructions or the directions were to simplify each expression, and then we're going to write the final answer using only positive exponents. So in number 17, we're going to be using the division property, which says when you're dividing, what you do is you're going to subtract the exponents of the exponents that have the same base. So you're going to take the x's, you're going to keep the x as x, and then you're going to take the exponents 5 and 3 and you're going to subtract. And then you're going to do the same rule with the y's. Keep the base a y, you don't change the base at all, you just kind of merge them into one base, and then you're going to subtract the exponents, which is a 4, and then this y has an exponent of 1. Okay, simplifying that out, we get x to the second power, y to the third power, and that would be how I simplify that expression. And you know it's simplified because there are no negative exponents in my final answer. In number 18, what you want to do is, if you start a problem with negative exponents, the first thing you want to do before you apply any rule is rewrite the problem so that you have only positive exponents. Okay, so a to the fifth is positive, so I'm just going to leave it where it's at. A to the second power is positive, so I'm just going to leave it where it's at. But b to the negative third power, I'm going to move from the numerator to the denominator, and when I do that, the negative 3 becomes a positive 3. And I do the same concept with the b to the negative 5. I'm going to move the negative 5 to the numerator, but the negative 5 becomes a positive. Okay, now I'm going to use the quotient rule, which says I'm going to keep the base and I'm going to subtract the exponents. So I kind of merge the bases together as a into 1a. I subtract the exponents. Do the same with the b's. Keep the base the same, merge them together into one base, subtract the exponents. So my simplified version is going to be a to the third power, b to the second power for number 18. Number 20, you can see even before I'm going to do any rule that I may apply, first thing I'm going to do is I'm going to rewrite the problem. I'm going to leave anything exactly where it's at that has positive exponents, and then I'm going to rewrite anything that has negative exponents as positive exponents. So this p to the negative third power is going to have to go from the numerator down to the denominator, but it's going to become a positive 3. The 2 will stay where it's at. The m to the negative 7, I have to move from the denominator to the numerator, but now it becomes a positive 7 exponent. The n to the third power can stay right where it's at, and the p to the negative 8 power has to be moved up to the numerator, and then the negative 8 becomes a positive exponent. Now, when I do that, I'm going to combine any exponents that have the same base together. But the first thing that I do here is notice I have coefficients of 4 and 2. So since this is a division problem, you actually divide these. So I'm going to go 4 divided by 2. Well, that's going to be 2. Okay, then I'm going to start with my m's. Notice I have an m to the second here. I have an m to the seventh here. The rule is when you're multiplying, and these are being multiplied, you add the exponents up. So you merge the two bases into one base. I'm going to add the 2 and the 7 together. Then I'm going to simplify the n's. Okay, I'm going to merge the two n's together. Since I'm dividing, I subtract the exponents. We call that the quotient rule, and I'm going to use the quotient rule where I subtract the exponents with the base of p's. Simplifying this problem out, I have a 2, I have an m to the ninth power, I have an n to the second power, and I have a p to the fifth power. That would be my simplified expression for number 20, and I know it's simplified because I have no negative exponents. Okay, number 21, switch colors so you guys could decipher between the two. So the first thing we're always going to do is if you have negative exponents, and you can see I have a couple negative exponents, I want to rewrite my expression as having nothing but positive exponents. Alright, so the 21 I'm just going to leave alone. The 7 I'm going to leave alone. The x to the 7th I'm going to leave. The x to the negative 5, I have to move from the denominator to the numerator, but now it becomes a positive 5. The y to the second and the y to the 8th, I don't have to move at all right now. And the z's, I have to put the z to the negative 9 on the numerator, make it positive 9 exponent. And the z to the negative 4, I have to put on the denominator and make it a positive 4 exponent. Once I do this, I'm now going to use my rules of exponents. So my first rule is I have my coefficient numbers, the 21 and the 7, you divide those out. 21 divided by 7 is 3. Then the x's, because they're both on the numerator, that means they're being multiplied. I'm going to keep the bases x, kind of merge the two bases into one base, and I add the exponents. We call that the product rule. Then I'm going to use the quotient rule for the bases of y's. So I'm going to subtract the exponents. So I'm going to go 2 minus 8. And then I'm going to use the same quotient rule for the z's. So I'm going to subtract the 9 minus 4. Simplifying this problem out, I get 3 x to the 12th power, y to the negative 6th power, z to the positive 5th power. Okay? Now, that cannot be my final simplified solution because I have a negative 6 in my simplified expression. So now I have to rewrite this entire expression as only positive exponents. So remember, we think of this as being a fraction, this part right here, there's nothing underneath it right now in the denominator, but we're going to have to move. So anything that has a positive exponent, you leave in the numerator. So the 3, the x to the 12th power, the z to the 5th power will stay in the numerator, but then the y to the negative 6th power will become a y to the positive 6 in the denominator. That's my simplified expression for number 21. Okay? Okay, so now when I get to number 23, what I'm going to do is I'm going to use the power rule. So the idea here in 23 is I take the outside exponent, which is a 3, and I have to apply that to everything on the inside. So that outside exponent of 3 applies to the coefficient of the 3, and it also applies to the x to the 2/3 power. Okay? And now I'm going to simplify that. So 3 to the 3rd power, that means 3 times 3 times 3. So that's 27. And now when I simplify the x's here, what I do is I take the 2/3 power and I'm going to multiply it by 3. Okay? So that becomes 27. X, 2 times 3 is 6, so I get to the 6/3 power. Simplifying that, 6 divided by 3 is 2, so I get 27x to the 2nd power. That would be my simplified version of number 23. Same idea in number 24. I take my outside exponent, I have to apply it to everything on the inside of the parentheses, so that 6 will apply as a power for the 2, and it will also apply as a power or an exponent for the x to the 1/3 power. Then I want to simplify this out. 2 to the 6 is 2 times 2 times 2 times 2 times 2. That'd be 4, 8, 16, 32, 64. So 2 to the 6 is 64. And then to simplify the x's, I multiply those exponents together. So I'm going to go 1/3 times 6. That would be 6 over 3. So this simplifies to 64 to the 6/3 power, which simplifies to 64 to the 2nd power. Okay? And I'm going to leave my answer as that. I could figure that out, and it's going to be a relatively larger number, so I'm just going to leave it. Okay? Moving over to the 3rd page, the only problems that I wanted you to do was number 32 and number 33. All right, and this is where we're asked to write the problems in exponential form. And we have a radicand inside the radical symbol that has a fraction as an exponent. And then we have an index of some number in number 32, it's 5. So to simplify this, what you do is you take the x to the 3/4 power. Okay, that's going to put it in exponential form, that's going to be your base with your exponent there. and then you're going to raise that to the power of 1/5. Now the reason why you're raising that to the power of 1/5 is because this x, in a weird sort of way of thinking about it, has an exponent of 1. Okay, now to simplify this, I multiply my exponents together. So I would keep the base of x, and then you would multiply the 3/4 times the 1/5. That'd be 3 times 1 is 3, 5 times 4 is 20. So number 32 would simplify to x to the 3/20th power. You cannot, if you could reduce that fraction, you would, but that cannot be reduced. Okay, same concept in number 33. We think of this as entire radicand as to the power of 1. So then when I rewrite it in exponential form, I take my radicand, which is x to the 2/4 power. That's going to be in parentheses, and then I raise that to the power of 1/3. And then to simplify that, I multiply the exponents together. So then I would take the 2/4, I would multiply it by the 1/3. That would be 2/12. So this would become x to the 2/12. And this fraction could be reduced by dividing the numerator and the denominator by 2. So this would reduce to x to the 1/6 power for number 33.